Hello, welcome back to Geometry Virtual Learning. This is lesson 2 on Sine Rule. Here we'll be talking about using Sine Rule to work out missing sides of triangles. And as usual, we go through exam style questions. If you haven't watched Sine Rule 1 on missing side, I recommend you go back to watch that before looking at Sine Rule 2, focusing on missing angles. For working out missing angles, the same way we derived sine rule for missing side is the same thing. The only thing is that we do the inverse of what we had before. For a side, we had a over sine a in that order, but for angles, we quote it rather sine a over small a sine b over small b in that order. So just take note. The inverse of what we had for the side is what we use for angles. When do we use sine rule for missing angles? We use sine rule when you have two sides and an included angle are given. You can find missing angles using sine rule. When you have two sides and an included angle, you can use sine rule to find missing angles. What do you mean by non-included? An included angle means that the angle shouldn't be between the two known sides. For example, in this triangle, I have 9 cm as this length and 6 cm, and I have angle 50, which is not between these two known sides. So this is what we call non-included angle. When it's between the side, it's called included angle. So it's technology for you to remember. So two sides and an included angle, you can use sine rule to find missing angles. As usual, you need only two of the ratios to set up your working out, and the labeling is very important. Despite the labeling, label the missing angle big letter A and the opposite corresponding side small a. Another known angle capital B, and the side opposite the known angle small b. So let's look, and in using sine rule for angles, we are going to use the inverse of sine. We are going to use the inverse of sine. So this is the symbol, sine -1. So don't forget, angles, we use the inverse of the sine. Example, we are supposed to work out angle x. Remember, we need pairs of information, angle and a side, a missing angle and a side. So let's check. A missing angle and a side, a known angle and a side. So it conforms. We are going to quote the first two ratios, but we need to relabel our triangle to help us know which is A and B. Missing angle is the A, and the side opposite is small a. A known angle is the capital B, and the known side is a small b. Now, first two ratios, substitute. So sine A will now be sine x over 9 is equal to sine 50 over 12. The more you practice, you get used to the substitution. You just replace each with whatever is there. Now, you got to be careful here. We are going to multiply through by 9. Multiply this by 9. You cancel this 9. Multiply this by 9. That's the first step. We want x, not sine x, so we need to get rid of the sign. That's why we need to use the inverse of the sign. So we are now going to find the inverse of all this information. So this is what it's going to look like. Now here, be very particular about how you use the calculator. Before you do it, you check carefully. You start by pressing the shift function. And press the sign. Shift sign. You see this there with a bracket. Key in order you need for the numerator, 9 times sine 50. As usual, close the bracket. At the end, go to the bottom cursor, push it to the denominator, key in 12. Go to the right of the cursor, click on that to push the cursor to the very far right. Then you close the bracket again. And if you've done it correctly, on the screen of your calculator should look exactly the same as what you see here. So I suggest you pause the video, practice that. Once you've got exactly what you see on your screen, then you hit the equal sign. So the answer is 35.1 degrees. 35.1 degrees. Let's look at another example. We check, we need pairs of formation, a missing angle and a side, a known angle and a side. So it conforms. But in the question, we are supposed to work out an obtuse angle. An obtuse angle. So our answer should be an obtuse angle. Let's see what happens here. We label. Missing angle is big A and a small a on the side. Known angle big B and a small b on the side. Code the first two ratios, substitute. Multiply through by 15 to cross off this 15. Get rid of this sign by doing the inverse of the sign. On the calculator the same way. Key in shift, sign. You get the sign, -1 with a bracket, open. Key in numerator, close the bracket. The bottom cursor, push it down. Key in 6. Right cursor, push it to the far right, close the bracket, hit equal sign. Wow. Now this angle is not obtuse. It's acute. But we are not wrong. But that's not the final answer. Now I'm going to show you reasons why it's like this. You don't necessarily have to do this in an exam. But I just want to show you why this is like this. If you look at this information, there are different ways or two different ways that this could be drawn, preserving the same information, 15 meters, 21 degrees, 6 meters. How do we do that? Like this. This 6 meters is the same as the 6 meters. The information is still preserved because we're not given the length of AC, so it could be shorter, it could be longer. So this is what we've calculated. This is acute, 63.6. This is the angle we've calculated. And as you can see, this isosceles. So this is the same angle on this side. And you realize that to find y, all that you need to do is to take your angle that you've calculated from 180. So when that happens in an exam, all you need to do is take your answer away from 180. So this is just an explanation for you to understand why it's so. And therefore, the answer is 116.4 degrees, and that is the obtuse angle we've been asked to calculate. Now, exam style question. Pause the video and read the question. A town has two radio stations, A and B, in the proximity of a garage. Station A is 2 kilometers on a bearing 100 degrees from the garage. The bearing of station B from station A is 145 degrees. The garage and the station B are 5 kilometers apart. Find the bearing of the garage from station B. Answer in 2 decimal places. Right, so this is trigonometry in connection with bearing. So if you haven't watched my videos on bearings, I suggest you go and check my videos on bearings. Now, from the look of things, all the question wants us to do is to find the bearing of garage from station B. This is station B. So the bearing of the garage is from the north all the way to this point. That's the angle we're supposed to work out. How big is this angle? Now, we can do that if only we know this small angle and this little angle. Because once we know these two angles, we know angles around a point is 360. We take these two angles away from 360, and that's our answer. So how do we work out these two missing angles? Okay, so we start. This angle is 35 degrees because from your rules of angles, these two angles are allied or co-interior angles, and they add up to 135. If you review your rules on angles parallel lines, you know that co-interior angles add up to 180 degrees. That's 35 degrees. All we need to do is to find this angle. We also know that this is 80, another co-interior angle. add up to 180. Now angles around the point is 360, so we can use 80 and 145 to work out this missing angle. That's 135 because angles around the point is 360. Now let's label this angle X and let's check if you have the pairs of formation for sine rule. A missing angle and a side, a known angle and a side. Yes, it conforms that. So we just say sine X over 2 kilometers is equal to sine 135 over 5 kilometers. That's what we have here. We multiply through by 2 to cancel out these 2. Then we find the inverse of sine on this and follow the same procedure. We have 16.42. So once we know 16.42 and 35 degrees, we can add these 2 and take it away from 360. So y is 360 minus the addition of the 2 angles, and that gives us 308.58 degrees. So our y is now 308.58 degrees. And that brings us to the end of lesson 2. Hope you've enjoyed it. Please share with your friends, and let's make Geomega Virtual Learning a bigger learning platform. Look forward to lesson 3. I'll be talking to you how to use sine to work out area of triangle. Lesson 3, how to use sine to work out area of a triangle. Thank you very much.